Are you currently tracking KPIs that highlight the average situation? Has tracking the average situation led you to make improper staffing or resource allocation decisions because you thought that the data supported it? Today, I'm going to discuss a best practice visualization that is a game changer for understanding how a process is performing. Say goodbye to those misleading averages that have been holding you back and get ready to embrace the power of the multi-vari chart. Let's say you operate a call center and your goal is to make sure that your customers are getting responses within the benchmark that you set. Let's say that's 20 seconds. As the operator of the call center, you may wonder, how long does it take for your customers to reach a call representative? And does that wait time vary over time? So to answer these questions, you go out and collect data on the calls that are coming into your call center, the date in which they came in, and the amount of time those customers waited to be connected to a call representative. Now, with thousands of records of data, a common first step is to simplify the data so that you can have an easy talking point and compare that to your benchmark. So that talking point might be, on average, people wait 15 seconds, which is faster than our benchmark of 20 seconds. So our performance might be good. And a way that we may represent how that average changes over time is by demonstrating the data in a time series. Up at the top here, I have calculated the averages with a pivot table of the wait times from April to July. And a simple time series may look like this, where we have April, May, June, and July on the x-axis. And then we're going to have the wait time on the y-axis. Let's call that 150 seconds. Now, April was about 50 seconds, so we'll put a dot here. May was about 62 seconds. June was about the same, and July was about the same. And if we draw a line in between those dots, we then get a time series view and can see how these data change over time. But what are we missing here? The distribution within each of these time periods matters. If we zoom in to a handful of calls here, what we can see is that the vast majority of these calls well exceeded our expectation, while one call waited 120 seconds to be connected. Now, if we fixate our view on the average here, the average of these 6 calls is 29 seconds, which is well above our benchmark. And we may come out with a decision that says our calls on this day didn't meet our benchmark and we were slow. Perhaps we need to make decisions to make this particular day faster in response time and start staffing that day with more individuals. But in reality, if we view the distribution, we can see that it was only one particular call, and perhaps that call, there was an issue with the connection or it was logged incorrectly. And instead of making decisions around staffing, perhaps we should address that one particular issue that we had throughout the day. Focusing on the average can lead you to make decisions that actually aren't supported by the data. And that's because we aren't keeping in mind the full distribution. And this brings us to the multi-vari chart. The multi-vari chart demonstrates the range as well as the average. If we go back to our call example, the range is what is the shortest wait time and what is the longest wait time. If we focus just on the week of June 25 here, the longest wait time is at the top of the chart here, around 120 seconds. And the shortest wait time is around about 5 seconds down here at the bottom. And then our average is the cross line in the middle. If we plot this over time, what we can then see is, okay, how does this variation change over time? And what is our average customer seeing over time? We get to see the slowest wait time as well as the longest wait time. And we can measure that against a benchmark to then say, okay, are we meeting that benchmark or are we not meeting that benchmark? If we want to answer how these wait times may change over the course of a day, we could plot the x-axis as the hour of the day. And what we could see here is our variation gets much wider as the day goes on. We also get further away from our benchmark at hour about 15, and we get closer to our benchmark around hour 17. What these data could perhaps tell us is maybe we're making staffing decisions where we are bringing in too many folks at the beginning of the day, but we don't have enough coverage at the end of the day. Looking solely at just the averages here, we don't really have much of a picture on what we should do. All we can say is, as well, in general, we're not meeting our benchmark. Now let's look at even, does the day of the week or the weekday matter? In this visualization, we throw the weekday on the x-axis, Monday through Friday. And what we can see here is that Monday and Thursday, our variations are very small. In layman's terms, when people call in, they should expect about the same wait time as everyone else who's calling in. But on Tuesday and Wednesday, it's a basket case. We don't know if you're going to wait 120 seconds, or maybe you just might wait 5 seconds. There's a lot of variation in between those 2 days. Now, how do we use the multi-vari chart for our clients? One of our lending clients was receiving feedback from their customers that requests for funding was taking too long. The company used 2 third-party companies to evaluate and submit the funding request. And our client, the lending company, established an SLA solely based on the average wait time. And in general, what you can see here with this multi-vari chart is the third-party companies met that SLA. All should have been good, but since the customers were coming back and saying, wait a minute, it's taking too long for us to get our money, it raised some red flags. Demonstrating these data in a multi-vari chart, we can see at the beginning of this time series, there was a ton of variation in their funding request. And this company one here, although they very closely met the SLA, some customers were waiting well over a month to get their money, while others were only waiting a few days. Since viewing these data with the variation in mind, as well as the average, our client was able to talk to the third-party companies to figure out, hey, why are people waiting so long in these particular circumstances, and what can we do about it? The proof is really in the pudding. Not only has viewing these data in a more wholesome manner decreased the variation, the client has been able to change their SLA not only from 10 days, but now to 7 days, because they've addressed the extremes in the distribution. So focusing on the variation rather than just the averages led them to a result where their customers are now happier. I hope this presentation helped you realize the power of the multi-vari chart and the pitfalls of pigeonholing yourself at only looking at the average in order to simplify data. The multi-vari chart here will lead you to more powerful insights and actions that can help you optimize a process, make it more efficient, make it faster. I'd love to know down in the comments how your business can use the multi-vari chart to help optimize processes that you have. If you like this video, please leave a like, subscribe for more. Thanks.